The second half of this practice worksheet focuses a little more on average rates of change, percent, growth rates, looking at linear functions versus exponential functions. And this is sort of hinting at where we're heading during our next class lesson. So the first problem here, we have a gas station owner that finds that for every penny that they increase the price of gas, that gas station owner sells less gas per week. And I know that seems like a weird thing to be creating a rate of change of, but basically there is an input and an output. And the key with identifying an input and an output is like, what are you intentionally changing? That should be your input. And then what is changed based on that becomes your output. So in this case, the price of gas becomes our input. So we're going to say, I'm going to actually change that color to purple and say, okay, the input is the price of gas, and the output is then the number of gallons of gas sold per week. Now, this is a proportional relationship. It's an absolute because given this 1 cent increase, I know that my output's going to go down 120. So if I'm told that she's raising the prices by 10 cents, that basically means that I am dropping the number of gallons I sold 120 gallons 10 times because there's 10 cents. So you could almost think about it. It's like, 1 cent led to, a decrease in 120. So if I, drop it 10 times or raise the price 10 times the amount, I'm going to increase the fewer gallons also 10 times the amount. And so 120 times 10 would be negative 1,200. And so she's going to sell 1,200 less gallons of gas. Now, what if she decreases the price by 5 cents a gallon? So this time, instead of going up to 10 cents, 10 times the amount, we're going down. So we're sort of going from 0, 1, and then we're saying, okay, well, she's going down to 0, 5. So it's almost like times a negative 5, like, oops. And so while normally, her gas sold decreased, if we're going down 5 times the amount, I'd end up actually increasing the amount of gas she sold. And so 5 times 120 would end up being 600. And so she would sell 600 gallons more. And this is just a sort of looking at rates of change and thinking about that constant rate of change. I could have gone through and just added 120. So if you normally decrease 120 for each cent, it goes up, so then therefore if we decrease each cent, we're going to go in the reverse direction, and I could have added 125 times. So this problem is really focused on sort of looking at this idea of an average rate of change and how does it impact in numbers. So I'm just going to make a note to the side, average rates of change. All right, the next problem, we're actually going to sort of be thinking more in line of creating a function. So gas stations in the U.S. dispense gas at the rate of